In April 2026, I released a video about how Niantic was using your data to create a large geospatial model. I wasn't expecting thousands of comments when I wrote that script, and I didn't anticipate how many of those comments would come back with roughly the same theme. Many of you said something along the lines of, "This is why I spoofed my location," or quote, "Joke's on them, I scanned the ground." This tells me that many of you didn't spoof just to catch that regional Pokemon in Paris or Sydney, but that you did it to fight back. You did it to poison the well, and it was not very effective. After reading some of those comments, I did what I always do and I checked to see if it actually worked. It doesn't. And it doesn't for two distinct reasons, and the second reason is one that no one in the comments saw coming, not even me. To begin, we need to understand what truly happens when one does an AR scan. First, you need to give Niantic access to use all the information transmitted from your device's camera, including data from accelerometers and GPS sensors. Second, the Visual Positioning System, or VPS, then locates you by matching your camera image against a stored 3D map. Many of you were keenly aware that these maps already came crowdsourced from Niantic's earlier app Ingress, and filled in more from Pokemon Go and acquisitions. But now, Niantic's VPS only uses a rough GPS reading to know which map to check against and only returns a position if the visual match gives a green light. I mentioned in the first video that the purpose of this technology is to work where GPS isn't optimal. So it's not a stretch to say that spoofing your location didn't exactly poison the well because your GPS location was only ever a hint. And it wasn't even an important hint to the training data. The whole goal of Niantic Spatial's VPS product is to be a reliable alternative to GPS. That means it doesn't train on GPS data. It's offering a replacement, not an enhancement. By Niantic's comparison on their site, GPS has large ranges of accuracy that could be as tight as 3 to 5 meters in good conditions, or 50 meters or more in bad conditions. Niantic's VPS boasts centimeter accuracy, which is far superior to GPS. I'll come back to this in a few moments, but one feature Niantic Spatial boasts about is its robust data set. It uses industry-leading research, that's you, to feed deep learning models to ensure its robust performance. So your GPS coordinates were simply a rough hint, a label, or a filter, not a trainable data point. That means that what Niantic built was never reading what you were faking. Now let's talk about the other claim. Many of you either said or agreed with statements like, quote, "I spoofed my location and I didn't scan." Well, as I just covered, if you think your GPS coordinates poisoned any data, you're wrong. The map's data is only player scans. If you don't scan anything, no data is transmitted. You contributed nothing, but you also ruined nothing. Others of you mentioned or agreed with statements like, quote, "I didn't spoof my location, but I scanned the ground." You were really there, and you really scanned something near the landmark. In this case, the data does enter the pipeline. It still doesn't poison anything. Let's talk about why. First, a scan is a video of about 15 to 30 seconds of a way spot or a landmark. It's an area of interest determined by the players. After your data is anonymized, the video is split into frames to build the 3D model. For each frame, they grab the image itself, the GPS location, remember that's just a label, your camera's sensor data, and your camera's position in relation to the way spot in the frame. At this point, there's still not enough data to determine the location. That happens later. Second, each split scan is transformed into 3D maps of the object. This transformation is what enables Niantic to determine the position and orientation of the way spot from the player's perspective. The third step maps the scans in relation to one another using GPS information as a filter, and here's the key part, I'll read it straight from their docs. Niantic minimizes errors and rejects outliers via a global bundle adjustment process to ensure each connected component is geometrically coherent. So they take in all the scans, and by the time it gets to actual mapping, they've already thrown out the pictures of your feet. At worst, you spent a few cents in processing power. Fourth, the map is reconstructed as a depth map, which is then made available to developers in 8th Wall's Web AR platform. This is a now open source platform that allows users to, quote, "create AR experiences that work without an app." Finally, context is added into each pixel to classify each object in the image. Pixels then contain information about the image, like if it belongs to a tree, the ground, building, or another object. Now, here's the rub. According to the 8th Wall docs from 2025, a location needs to have at least 10 quality scans, with the first and last scan being at least 5 hours apart. The eligible pool of scans was then sent through an algorithm to pick most scans. These would be the ones that are clearly the object, while others would be held back to validate quality. Anything that wasn't quite right would be sent out for further review. So what does that mean? A ground-only clip would either fail the minimum quality check and be rejected outright, or it would be viewed as one low-rated input among many. You may not have done the scan properly, but we can be sure that hundreds of thousands of others did. That means your single poorly scanned waste spot would be diluted in popular spots, or a brief dent at a less popular spot that gets smoothed out as more good scans arrive. If your scan doesn't make geometric sense, it's thrown out. If your scan doesn't match the rough GPS points, it's thrown out. Niantic had a way to correct for the attempts to poison the data. Well, what about the location metadata? I did say before that each image carries location metadata, so wouldn't a fake coordinate get into the dataset? Yes, it does, but Niantic's VPS is smarter than that. It doesn't necessarily trust the GPS data since it knows GPS is pretty inaccurate even in the best circumstances. The position that the VPS trusts comes from the image match. Niantic's algorithms look through the frames of each scan and make sure it makes sense beyond just blindly trusting the GPS coordinates. It checks that the images sent in match the images it already has for each waste spot, which, if you remember, comes from previous scans in Ingress and even from developers using a platform called Wayfarer. The image for the landmark likely already exists in Niantic's map from those earlier scans. The VPS is simply checking that each frame from a scan matches geometrically with the object. It doesn't poison anything because it can't reconcile to the correct map. Remember, the GPS coordinates are a label and a filter. There are a bunch of different maps to choose from, so the photo's GPS coordinates filter down the options. If a scan's GPS coordinates don't match up with the known object's coordinates, the scan just gets discarded. I mentioned at the beginning of this video that we'd talk about Niantic Spatial's boast about robust data. This is actually the secret sauce to their reliability. The datasets that Niantic has collated across the years are massive, and while some of you may have sent in lower quality data, there are many who were true to the scanning process. So all that low quality data was a bump in the road that was paved over when the next person came by and did a proper scan. You see, VPS reliability comes from many overlapping scans. These overlapping scans across many different conditions mean that quality and fidelity of the 3D model of the object increase despite attempts to submit lower quality information. The scans are compared to other similar scans, so that information becomes an outlier and is washed out in a sea of normal data. The only way that would work is if a majority of players submitted data this way. And spoofing? That was never Resistance. All that effort was only theater. It was a play put on for a machine that was never the real audience. What was worth pushing back on was happening offstage the whole time. This is only the first reason why your attempts to poison the data didn't work. The second is worse. Waste spots originated as ingress portals, which were nominated by players through their Operation Portal Recon. This became the Wayfarer platform. Niantic couldn't go out and catalog every town itself, so it turned to players to vote locations in. But only one scan in a single weather condition is not a high-quality signal. That's where you came in. Niantic has always treated the player scans as high-quality ground truth. The player data is what made up for the lower-quality datasets found from satellite, aerial, or street-level imagery. Their philosophy back then and still today is to train in highly concentrated places and generalize the data outward into less concentrated places with lower quality data. And apparently, they got enough of that data fairly quickly because they've moved on. In May 2026, Niantic Spatial partnered with drone company Spexi to use that imagery to train their models. So now Spexi, a company that pays drone pilots to do, quote, missions in their areas, is feeding data to Niantic's large geospatial model. All the places people can't reach are now captured from the air and fed into the same model first crowdsourced from Pokemon Go players. But hey, at least people are getting paid this time. In return, Niantic opens up its modeling API for Spexi customers to use, and Niantic customers can use Spexi data in their mapping. It's a win-win for the companies. Your captures were never the thing you could spoil. Those bad scans would be washed out in the sea of good scans. But still, your scans became the baseline the system generalizes from, and now data you had no part in collecting is being layered in. So now, today, if you're still spoofing to beat the system, who cares? If you're covering your camera with your finger or pointing the camera at the ground, what does it matter? Pokemon Go players already built the engine, and enough players contributed to get the drone program off the ground. You never poisoned the well. You never poured sand in the engine. You were the engine. And now they've moved on to the parts you can't reach. It was opt-in, so if you scanned, you said yes. You just said yes to something a lot smaller than this. If we're honest, it feels really good to say things like, "I fought back by feeding the machine garbage." I think that's why this sentiment spread and is so popular. It is a satisfying ending to this story. However, it's an ending for a different story. There was never a fight. The system never read what you faked. It was much too smart for that. And now the system doesn't even need us. The technology is impressive. The methods by which Niantic Spatial acquired the data are genius, and they are solving a real-world need using the data that they acquired. I'm not arguing any of that now, and that wasn't my argument in my last video about Niantic. The argument is now and has always been about consent. And yes, it was opt-in. We're all very aware of that fact. If you scanned, you tapped the button that said you agreed. That was never in question. The question is whether tapping a button for an in-game reward is the same as agreeing to help create a commercial large geospatial model. The very same geospatial model that has since been split between multiple companies to profit off you through delivery robots, AR glasses, or anything that can pinpoint a person's location with shocking accuracy from a single photo. Pointing your frustration at something that can't feel that emotion leaves the real problem where it was. Before you spoof to make a point, ask who the point even reaches, because right now, that's nobody. But what do you think? Am I still missing the point? Is there an angle that I missed? Or is this still blown way out of proportion? Let me know what you think in the comments, and until then, I'll see you in the next video.